This is done by Miss Ariel Leong.
It's obvious.
Her paper is hard. Yeah. Miss Ariel Leong is my first mentor when I came into HR. Alright. Okay. Actually, this function, this exponential function is not something that is new. This is also in EMATH. Alright. This function is also in EMATH. So what is this function used for? I want to remind you guys again before we actually do the sketch. Okay, it's an exponential function. When we talk about something that is exponential, we are saying that something grows very explosively. Okay, it grows very large over time. Okay, so when you look at this equation, can you please write down this equation at the side? I just want to remind you of a few things. Y equals to AX. Alright, this A over here is our growth rate, or you can think it's the growth factor. Okay, so it's basically same but different, right? So it really basically logarithms is just a inverse of our exponential function. Okay, the x over here represents the number of times we combine, not combine but compound. Okay, so you can think of the number of times. Okay. Just write it as times lah, okay? Don't need to make it too complicated. And your y is basically your result. Right? Your y is actually your result. Alright? So I want you guys to remember these few things and let us straight away get to doing it. Alright? So they actually asked us to use a spreadsheet. No lah, we're not going to use a spreadsheet. We straight away look at the answer over here. Okay? So this is the graph of how a exponential function is going to look like. Okay, this is a graph of how an exponential function is going to look like when your growth rate or your growth factor is more than 1. When your growth rate or your growth factor is more than 1, it means that over time it will increase. Okay, it will increase. Okay, and it doesn't really matter what exactly is your growth rate. As long as it's more than 1, it will have this shape. Okay, it will have this shape that goes up. Okay, we call this part exponential. Okay, we call this part exponential. Yes. EMATH. Yes. Yeah, exactly. This is the graph of a to the power x. Okay, so the function that we are actually graphing is this. Okay, this is also tested in EMATH. Okay, this is also tested in EMATH. John, please take this first. No, wrong one. Yeah. Okay, now let us get to this. So there are a couple of things that we have to sketch. Okay, can you just put this is your part 1? Okay, this is your part 1. Let us sketch this part 1 first. Okay, so let us get familiar with a basic shape of our exponential function. So the basic shape of an exponential function, okay, you will first draw your Cartesian coordinate. This is the y and x. Now in AMATH, the axis will not be drawn for you. You have to draw by yourself. Okay, that's the thing about AMATH. So you have to learn how to draw by yourself. In EMATH, everything is drawn for you, but in AMATH, it's not. Alright, so how does it look like? Just remember, exponential means it will start from nothing and then it will go upwards. Okay, I want to pause at this sketch for a while because there are a few things that I want you guys to be very familiar with. Now, remember, in your graph that you are sketching, y equals to a to the power of x, I told you guys that x actually refers to the time, right? So in reality, let me give you a scenario. Alright, let me give you a scenario. In reality, it could be something like exponential growth is normally used when you're talking about money. Okay, money is one example. So we can say that maybe we want to chart maybe one of your bank account over time. Okay, so y is your end result. Okay, so let's use this as an example. Let's say we talk about the amount of money that you have in a bank, and t is the time, right? So I'll say maybe this is time. We can treat time like hours, or we can treat it like years. Doesn't really matter. Okay, but let's say this is the number of years or the amount of hours. Doesn't matter. Okay, so when you look at this graph, we can understand when your time is equals to 0. When your time is equals to 0, you realize that this person starts with a certain amount of money, right? So we can say that the normal scenario will be when Tom starts investing at 18 years old, he had $1,000 in his bank. Now this amount over here is $1,000. This is the amount that he initially started. Okay? And then of course we know that over time, maybe in 2 years, in 3 years, his bank accounts grow. Okay? But the key thing I want you guys to think about is what does it mean when your X is negative? What does it mean? What does it mean when the time is negative? Huh? You're losing money? No? I gave you the example, right? Let's say Tom at 18 years old, he had $1,000 to invest. Okay, so we know that he invests $1,000 when he's 18 years old and he compounds it, definitely the growth rate is positive. But what does it mean? But when we look below the X, when X is less than 0, that means when we go to the negative territory, what happens to the amount of money that he has? It decreases, right? And in fact, if we go back far enough, where does this approach to? 0. Okay? So this is the key thing I want you guys to know. When your X is negative, basically we are going back in time. Okay? Okay? So means we are going back in time. So for example, if you go back in time when he is maybe 5 years old, maybe he only has $5 in his bank. And if you go back some more, maybe until he is 1 year old, you approaches 0, maybe he has $0 in his bank. Alright? Okay, so just remember this. When the X is negative, basically it means that he went back in time. Okay, he went back in time. Alright? Okay, let us move on. The next one. This is part 2. Can you write this as part 2? Let's draw it out. How does this look like? Now, I need you to know that when you have a negative X over here, you can actually represent it as, because negative X, 2 negative X, we can actually express this. We learn in indices, right? We can actually rewrite this whole thing as this. Okay, we can actually rewrite this whole thing as this. Okay, y equals to half x is the same as y equals to half the power of x. Do you realize that? For those of you who are a little bit weak in indices, we can take the reciprocal. Right? We can take this as the reciprocal because we know this is the same as 2x raised to the power of negative x. We can write this as the reciprocal, so it's going to be 2 to the power of x. Okay? Okay, so now that we know that, actually this one can be written as this, okay? And what is exactly is this? This is actually referring to my growth rate. When your growth rate is less than 1, when your growth factor is less than 1, how does it look like? I need you guys to really understand. Okay, so we're going to draw the Cartesian plane again. This is for my part 2. This is my y, this is my x. Now, if my growth rate is less than 1, that means as the time passes, my value should become smaller and smaller and smaller and smaller. Okay? But my total result, will it ever be less than 0? You think about it. Okay? If you think about an example like population growth. Population growth is actually very common, a very common example in exponential growth. Okay, let's say we have a population like Singapore that do not have enough children. So over time, our population will get smaller and smaller and smaller and smaller and smaller. But is it possible for the population to be negative? What does it mean by negative for ghosts? No, right? So it cannot be negative. The lowest it can go is we all go extinct, right? Go 0. So we know that we start at a certain number. I'm talking about positive. We start at a certain number and it should tend slowly to 0. So it will look something like this. Okay, it will look something like this. Then, but we're not done because we did not draw for x is less than 0. I want you to think about it. If x is less than 0, what does it mean? It means we went back in time, right? Okay, we went back in time. So for example, we know, okay, the world's population now is declining. But if you go back in time, was it larger before? Yes, right. So actually, the graph would look like this. Okay? Or if I have to redraw it a little bit better, it will look something like this. Okay, so when your growth factor is less than 1, you have this function over here. Alright, just one more to go. This is part 3. This one we have done before. When all I need you guys to do all I need you guys to do is just remember the basic graphs. Okay? I just need you to remember the basic graphs of the normal exponential one. Let's say in the exam they ask you to sketch, and there will be sketching in your exam. It's not just stating the value of A and N. There will be sketching in the exam. Okay? So let's say they want you to sketch the graph of this. Then how? The first thing you do is you remember I told you I'm going to give you a very simple example. If I got a graph of x equals to y equals to x squared, you know that the graph looks like this, a smiley face, right? But if I give you a graph of negative x squared, you know that the graph is a sad face. Why? Because when there is a negative sign, okay, when there's a negative sign, it is basically a reflection on the x-axis. Okay, it's just a reflection on the x-axis. So here, when you have a negative, actually, if you use the same concept, you would be able to know. You know that the positive version, y, x, the graph is going to look exponential, right? So it will look like this. If there is a negative sign, how will it look like? It will just be a reflection. So a reflection will be like this, the green color one. Alright, so let us sketch out this thing. A little space over here. Part 3. This chapter is basically all about sketching only. Okay, so just try your best to follow along. This is A math. This is A math. We won't go through E math until the paper is done. Alright, so this is part 3. Okay? So as long as you have a negative sign, it is a reflection in the x-axis. You guys must remember that. Why, Fanny? Got something on? Okay. Next one. If this is 10, if this is 10 over here, yes? Can you substitute the 2 inside the equation? What do you mean? Can you substitute x equals to 2? Oh, yes, you can also. Okay, so basically you are trying to do a table of values, then mark out the points and then draw, is it? Yeah, can also. Can also. Yeah, but it will be negative 4. Because there's no brackets. It's different from, this is a good question. Is this the same, okay, my question to you, is this the same as this? Is this the same? No, answer is no. In this case, is the entire negative 2 is raised to the power of x. But in this case, it's only the 2 is raised to the power of x. Okay, in this case it's different. Okay, you must take note. It's a very common question. It's a very common misconception. Okay? Okay, come let's look at the next one. Example number 2. Y is equals to 10 to the power of x. How does it look like? Actually, it doesn't matter. I repeat again, it doesn't matter what this base is. Okay, it doesn't really matter. As long as it's greater than 1, the shape will be the same. Just know that because this is 10, okay, in fact, what I want you guys to do so that you can able to tell the difference, can you first draw y and x? I want you to draw a very gentle slope. And this is y is equals to, let me, 2 to the power x, okay? Can you draw a y equals to 2 to the power x? So the increment is very gentle. Okay, the increment is very gentle. So it is still exponential, but it is more gentle. After which, I want you to draw the next one, which is y equals to 10 to the power of x. So what's the difference? The shape will be the same. Okay, the shape will be the same. In fact, it will cut through the same point here, but after which it will go up like this. Okay, so this is y equals to 10x. Okay, it will cut through the same point over here. Okay, it will cut through. Why? Because when x is 0, anything raised to the power of 0 is 1. So it will cut through at this point 1. Okay, but after this point, the 10 to the power of x will go up faster. Okay, will go up faster than the other graph. Okay, this chapter really very simple. Sketching, you just need to know the basic shape only. That's all. Okay, I'm spending a bit of time on it, but actually it's really very simple. Okay, come. This one is a little bit more confusing. Okay, this one is a little bit more confusing. Can we just put this as part 1 and part 2? And this one will come out. This one will come out, so you need to know. Alright. Let us do part 2 first. Okay, let us do part 2 first because it's actually very intuitive. I'll give you an example first before I do part 2. Let's say I have the graph of y is equals to x squared. Okay, you know that the graph of y equals to x squared is basically this, right? Right? You know that the graph of y equals to x squared is basically this. But what if I have y equals to x squared plus 2? Then how would it look like? Basically, my graph will shift up by 2 units. Here will be 2. Correct? So, whenever you have a plus or minus 2, if it's minus, it means it shifts down by 2 units. If it's plus, means it will shift up by 2 units. Is that okay? Okay, so we do part 2 first. So I know that the normal graph, this one don't draw yet, this one I draw first. Okay, I know that the normal graph will look like this, right? This is the graph of y equals to 10x. But since I know now is minus 2, what does it mean? It means that I need to shift this graph up or down? Down. So I need to shift this graph down. But the question is, how low should I go? Negative 2? Think about it again. Initially, it was at 1, right? If I shift down 2 units, where will it go? Negative 1. Okay? So here is the graph of negative 2. Okay, so this is part 2. Whenever you have this plus minus of anything here, okay, if it's minus, it means that it shifted down 2 units. If it's plus, means it shifts up 2 units. Okay? The next one is going to blow your mind. Okay, everyone done this already? This next one is basically the last one. Okay, then we are done for this subchapter. I tell you, this chapter is about sketching, a very simple one, but this is the key important one that will be tested, and I suspect a lot of you will get it wrong, but it's actually not very difficult if you really just listen. Okay, now, this is a bit different. Now, what is the difference between these two? Can you open your eyes a bit bigger? Okay, open your eyes a little bit bigger. Can you notice that this minus 2, right? This minus 2 is not on the power. Do you notice that? You must be able to see the difference because a lot of you will say, no, it's the same one. Okay, can you see that this example over here, at the bottom over here, is I have the normal function first, x to the power of, 10 to the power of x, and then I minus 2, means I shift it down 2 units. But the one on the top, this example over here, is my powers is reduced by 2. Okay, my powers is actually reduced by 2. Now, the way that I want you guys to see this, okay, is, I know this one can get a little bit complicated, but usually what we call the main function is our parent function. Okay? So when I say that I have like examples like y is equals to a to the power of x, this is our parent function. Okay, this is my parent function. And when I'm doing examples like number 2, I'm saying that my parent function move up or down, plus or minus 2. But when I have this, I have x minus 2, it is to the powers, okay? I am no longer shifting it up and down, I'm actually shifting it left and right. Okay, so that's the difference. Okay, and this part you need to know. Okay, so but the next confusing part, I think most people can accept that when I do this to the exponent, it's actually shifting left and right. Most of you can accept that. But the next part, you also must accept. Okay, next part also you must accept. Is that when it's minus 2, it's not shifting to the left, it's shifting to the right. Okay, and this part a lot of people cannot accept. Okay, for those of you with iPads, you can take out. I just want to prove to you, because sometimes seeing is believing. Sometimes if you don't see it for yourself, right? You will not believe it. Can you go to this website called Desmos? Can you go to this website called Desmos? And you click on graphing calculator. Okay, and I want you to enter in the function y equals to, let's use 2 raised to the power. Let's raise to the power. Okay, no, I don't want to. Raise to the power of x. Where's the delete button? Okay, can you do this? Y is equals to 2 to the power of x. Okay? Okay, for those of you who really don't have the iPad, then you look up. But sometimes it's much better if you really work it out yourself. Okay? And I want you to create another function. Okay, I want you to create another function. Same thing here. But it's going to be y equals to 2 raised to the power of x minus 1. Raised to the power, not x minus 1, raised to the power of x minus 1. But doesn't allow me to do that. Let me see. Bracket it? Does it work if I bracket it? Let me try. Yes, if you bracket it, it will work. Okay? Can you guys see the difference? When you minus 1, okay, the blue one is 1 step ahead. Okay, it's actually 1 step ahead. So it's basically like shifting the graph to the right when it's minus. Okay? When it's plus, you can just click on this one. When you change it to a plus, intuitively people will think that plus means shifting to the right. But when I put a plus, can you see that the graph is shifted to the left? Can you guys see that? Okay, so this is something that you must take note and remember. Okay? When you plus it, it goes to the left. When you minus it, it goes to the right. Okay, and this one is different from when you have the parent function plus minus. Okay, this part gets a bit confusing, but don't worry, we'll do more examples when the time comes so that you can be familiar with it. And this concept will be tested in the exam as well. Okay, you cannot run away from it, but you just have to remember lah. Okay, you just have to remember. Okay, let's go back to our example. Okay, so in this example number 1, okay, let me draw it out for you first. I have my normal function. I will always sketch out the basic function of x to the power of 10 first. So this is y is x to the power of 10. But since I have minus 2, okay, since I have minus 2, now intuitively I would think that minus 2 moves to the left 2 units, but I know that it's the opposite. So it's going to move to the right 2 units. Okay, but of course, because I have a simple sketch like this, it's easy for me Okay, so actually the graph is move forward by 2 units lah. This is not, this is -2. Okay? The only thing that you need to take note of is last time over here, okay, at this point it was 1. What do you think is the new value over here? What is the new value over here? What is the new value over here? And we can easily calculate that, right? When x is 0, what is my value of y? Substitute it inside. Alright, so what is my value of y over here? 0.01. Okay, that's great. Okay, so you must know over here, this point is 0.01. Okay, it's no longer 1. But the shape is basically the same. The shape is basically the same. Okay, when you shift it to the right or shift it to the left, it will have the same shape. Just take note of the y-intercept. Alright, Katie, come. Hey, I know this part is a little bit dry. This part is a bit dry, but it's something that you really have to get it. Okay? Okay, if not, let's move on to the next one. This one basically is a very common function as well. Okay? E is just a constant. Just need to know that it's just a number. E is a number that is greater than 1. So if they ask you to sketch the graph, you should be able to sketch it very quickly. Cartesian coordinate, y, x, you just need to know, okay, it's an exponential graph law, so you'll look like this law, y equals to e to the power of x. Okay? I'm going a bit faster now because I think we have covered the basics. Alright? Okay. Now, this one, let's think about it. If what happens when you have a negative sign? Okay, what happens when you have a negative sign? Let's use decimals and let's see together. Okay, what happens when you have a negative sign at the x? Remember just now earlier, right? I showed you guys that when you have the function y equals to ax, if, maybe I don't use a, I put this as 2, right? When you have a negative sign, this is a reflection across the x-axis. So actually I give you a clue. If this one now, you have a negative sign over here, if the other one is a reflection across the x, what do you think this one is going to be? The y. But let's show you, let's show us whether it's really true. Alright, so if I go back to decimals, I will plot out the exact thing. Okay, let me try and let me show you. Okay, so the function is e to the power 0.6 x. Okay, so the first thing first, I want you guys to notice e raised to the power of 0.6 x. The 0.6 basically has no effect on the general shape because it's just time. Okay, so it has no effect on the general shape. But what is going to happen? Let me see if I can copy and paste this. I can't, so let me try this. E. Can you also try it along? So sometimes seeing is believing, you have to do it by yourself. Negative 0.6 x. What happens? Can you guys see what happens? So what happens? So you have e raised to the power of x, that is the normal function that we know is the normal exponential function. But the minute we have this negative sign over here, okay, the minute we have this negative sign over here, we realize that it becomes a reflection. Is it a reflection on the x? It is a reflection on the y. Okay, so this is just some things to take note of. Alright? So here makes a reflection in the y-axis. Okay, so again, how does it look like? This one you can put part I, sorry. And this one I think it might be useful to sketch out both of the graphs. So you know that the normal y is equals to e to the power of 0.6x. And then you can sketch the other graph on how it looks like. Okay, so this is the graph of y equals to e negative 0.6x. Okay? So I say again, this chapter really requires you to memorize, okay, quite a few things. Okay, then the last one, this one is not something new, right? Negative 38 just means, actually we don't care about the coefficient, we don't care about the absolute number, we care about the signs. If this is negative, means it is a reflection on the x-axis. Okay, so this is a reflection on the x-axis. And if it's a plus 20, what does it mean? It is moved up or down. If this is plus 20, what happens? Move up. Okay, it's move up 20 units. Okay? Okay, so how shall we draw this? Let's draw this together. What happened? Okay, come, focus. Okay, last two, then we are done. Alright, so let us quickly sketch this. If this is a negative, basically, I am going to have it as a reflection. So I have a y and an x. A reflection means it is going to look like this. Right? So this is y equals to negative 38 e to the power of 0.6 x. Okay, and when my x is 0, here is basically negative 38. So, my question to you is, how are you going to draw this part 3? Without using decimals, can you think? Basically, I'm going to shift this up by 20 units. How would it look like? Can you draw it? Draw by yourself? I'm going to shift that thing up by 20 units. Hey, hurry up. Think about this one. Okay, think about this one. Hey, it's really gone already. There are so many millions of insects in the world. Then close the window. Okay, last one. Okay, I want you guys to think about two things. Number one, if I shift this up by 20, what is the new y-intercept? And the second one is that we know that this one will approach 0 as the value of x gets larger and larger. But if I shift it up by 20, what does this approach to? What is it going to approach to? What value will it approach to? Okay, these are things I want you guys to think about. Okay, yes. 0.6 is lesser than 1, yes, but that is not our growth factor. That is our time. You're talking about here, right? Yeah, it's less than 1 then. Well, what's the question? Hey, wait ah. Yeah. Okay, because it's negative, right? That's why we have this shape. We have this shape. So again, you can use decimals and you can plot out to see whether it's correct. Use decimals. What's your question? I don't get the question. Yes. Okay, good question. Okay, so actually this question we can look at it step by step. Okay, the first part is we have this y equals to e raised to the power of 0.6x. So we know that this is the correct shape, correct? This is this shape one. I can prove it to you over here on decimals. Can you see the y is this shape? Okay, but again, don't be confused with when the e is 0.6. When the e is 0.6, that is when it is this shape. Yeah. Okay, when the value, I know what you guys are talking about. Okay, I know this one can be a bit confusing. You need to understand that there are two different kinds of examples. When you have the graph of y equals to ax, when a is greater than 1, that means, for example, y equals to ex, you are going to have exponential growth. Okay, so this is y equals to e to the power x. But when a is less than 1, so for example, when I have y equals to 0.6x, okay, when I have this example, then it is no longer exponential growth, but it decays over time. Okay, so it's a different thing. Yes, can go. Okay, how can we take this pass first? Alright, okay, let's not waste enough time really. I think we have wasted enough time. So basically for this question, we are going to have the same thing. Okay, but this time round, it will cut it at what point? Negative 18. Okay, the shape is going to be the same. Okay, but this time round, it will approach. Here, if I have a dotted line, over here, it should approach 20. We call this the asymptote. Okay, it will approach 20. Okay, means it will tend towards 20. Alright, and this one will be tested also, so you must make sure you know. Okay, and this one I really need practice, but don't worry, we'll come, when the time comes, we'll practice a bit more. Okay, so let's go question number 1. This kind of question is really very simple. There will be one kind of question like this in the exam. It's really very simple. I'll show you one and then you do one by yourself. Alright? Okay, so question number 1. The temperature T of a chicken removed from a freezer is given by this formula over here, where T is the time in hours since the chicken was removed from the freezer. Part I, find the temperature at which the chicken is kept in the freezer. So in this case, what is the value of T that we must substitute over here? What is the value of time that we're going to substitute inside here? You must read the question and you must try to understand. 0. Okay, why is it 0? Because they say that T is the time that is removed from the freezer. So when time is equals to 0, the chicken is still kept in the freezer, hasn't been taken out yet. Okay, so what is the temperature? Temperature for part I is simply 20 minus 38e to the power of 0. And this will give me negative 18 degrees Celsius. Okay, how about part 2? Find the temperature of the chicken when T equals to 2, so that is easy as well. Just do a substitution. Minus 38e, negative 0.62. So enter this in your calculator. Hey, all of you can find the E on your calculator. Cannot find the E is here. Let me show you. Okay, can you find the E over here? Can you see? Okay, so you need to press alpha. Alpha is over here. Huh? The one at the lawn? Also can. I think both will give you the same thing, if I'm not wrong. Yeah, one of them is with power, one of them is without. But they are the same thing. Okay? So you should get 8.55 to 3 significant figure. Okay, next one. Express t as a function of big T. Okay, express the lowercase t as a function of the uppercase t. So how can we do this? Okay, so the way that we're going to do this is we want to make this t the subject of the formula. Okay, we want to make it the subject of the formula. So I have t is 20 minus 38e negative 0.6t. I will bring everything over to the other side that doesn't involve my t. So I'm going to get t minus 20 is equals to negative 38 e 0.6t. I will divide both sides by negative 38. Okay, so I'll divide by negative 38. If I divide by negative 38 on this side, this will be my result. Alright? And negative 38, I can bring it up. So essentially, it's basically just changing the sign. T 20 minus t over 38 is e 0.6t. Okay, and the next step. What do you think I should do next? What do you think I should do next? I give you a clue. We should use our logarithms. Okay, we should use our knowledge of logarithms to try to get rid of this e. So what do you think we could do? Okay? Now, I want to highlight to you something. I want to highlight to you something. Now that's it. Oh, I'm so sorry. Okay, just 1 more minute. Just 1 more minute. Basically, I can ln both sides. Okay, I can ln both sides. Why do I want to ln both sides? Because if you remember what is ln, ln is just log base e, right? So essentially is log base e of 20 minus t over 38. This is log base e of e negative 0.6t. What is log e of e? That will give you 1. Okay? So very quickly, so this one I can bring it down. This is basically my ln 20 over 38 is equals to negative 0.6t. So if I want to make t the subject, is basically ln 20 minus t over 38 divided by negative 0.6. Okay? We will continue in the next lesson.